Hello everyone, welcome back to MathLAB programming course. So far we learned a lot about matrices and vectors, and the reason that we're working on these topics is that the programming is dealing with all these features and how you can manipulate the functions in MathLAB to get the results, and there are always different ways to do that. So it is necessary for us to expand our knowledge in MathLAB. So in case that we are presented by a different sort of problem, we have some idea how we can approach that and actually solve it. Today I'm going to introduce you more of the matrix functions, which are really important. Let me clear the screen, the variables. I'm going to define a new matrix. So I define a new matrix. I'm sorry, I put okay, so I defined a 3 by 3 matrix, and now I'm going to calculate the trace. In this video, I'm not going to explain about the mathematical aspects of the things because this is not the purpose of this course. However, I'm going to show you how you can calculate different results which are related to matrices with MathLAB. So the trace, if I do that, it's 6. And what is the trace is the summation of all the diagonal elements in a matrix. We do have 1 plus 5. The result is 6, and it is the diagonal summation known as trace. The next one is rank. So rank of A, it's also very important. You can pass it through the function called rank, and if you hit enter, you see that the rank of the matrix is 3. It's especially useful when the matrix is not diagonal. So let me come to the first line and define a new function. 1, 2, 3, 4, 5, negative 1, 3, 9, and 3, 1, 9, 8. Okay, now I created a 3 by 4 matrix, and as you see, it's not diagonal. Let me calculate the rank of B, and you see that the rank is 3. If you're interested to further explore the meaning of the rank in matrices, you can also visit the MathLAB documentation, which explains every function in more detail. Let me clear the screen. Another important value we need when we're dealing with matrices is the determinant. And the way to calculate determinant is to pass the matrix into det function, which stands for determinant. And now, because we need a square matrix, you cannot calculate the determinant for those matrices which are not square. So I do happen to have a square matrix I define here, A. Let me type determinant of A. And if I do that, you see the determinant is going to be negative 24. If you have tried to calculate the determinant of a 2 by 2 matrix, it's going to be, easy and almost fast. But when it comes to a 3 by 3 matrix, it's going to be really time consuming. However, there are tools like MathLAB that makes this task super easy for you. To show you that the math determinant is only calculated with square matrices, let me calculate the determinant, the B, which is not a square matrix. If I calculate, you see that the error defines matrix should be squared. Let me clear the screen. The next important thing I wanted to show you here is inverse. So I do have matrix A, and I wanted to calculate the inverse. The way that we do that is through using INV function. INV of A just calculates the inverse of A. That's simple. How about B? If you do that, you realize we're not able to calculate the inverse for a matrix which is not squared. In this video, we'll learn how to do the rank, how to do inverse, and also the trace. I hope you enjoyed the course, and I see you in next video.